Hey viewers, we are back again. This week we want to start 2021. As last 2 weeks we engaged in solving 2022 JAM question. Now, before we start 2021, I have received a question from one student of Ahmadu Bello University Zaria, which the question is here. The question reads, a body is projected vertically upwards with a speed of 12 meters per second on the surface of a planet where the acceleration due to gravity is 8 meters per second squared. What is the time for which it stays above a height of 5 meters? Now, before answering this question, let me give you a clear image of what this question is all about. Now, this is the surface. And at this surface, I have a body. This body is projected with a velocity where this velocity is 12 meters per second. This body, when projected up as a result of pull of gravity, it will start decreasing in speed until it reaches a maximum height. Let's say from here to here is my maximum height, and at this maximum height, V is 0. If V is 0, then this body will be covering this distance from here to this very point. Now, when it reaches this point, 5 meters, let's say from here to here is 5 meters. It will take time to do so. Then from this 5 meters, it continues moving. Now the time it takes covering this very position is what we are asked to find. And let me name this capital letter T, which is the time it will take to stay above a height of 5 meters. Now, in answering this question, I have to find the time it takes from this point to cover this 5 meters. Let me call this T1. Then the whole time it will take to cover from here to here, I will call it T, small letter T. Now, at H maximum, we know that V is 0. Let T be the time to reach H maximum. If that is the case, then I'm going to use V equals to U minus GT. My V is 0 at maximum height. U, which is the initial velocity of projection, is 12. Minus G is 8, according to the question, 8 meters per second square times T, where T is the total time of flight. Now, this gives me T equals to 8 minus 8T, coming back to this side, it becomes 8T. Now, T is 12 over 8, which is equals to 1.5 seconds. Now that I've obtained the total time of flight, I have to find the time it takes to reach this 5 meters. In finding this time, all I have is U, G, H, and T, which means I need velocity with which this body will reach this 5 meter height. To get this velocity, let V be the velocity at H equals to 5 meters. To get this V, I will use V squared equals to U squared minus 2GH. Why we are using negative sign is because we are still in the what? Upward motion. Now, what is V? V is what I'm looking for. U is 12 minus 2 times 8 times 5. H is 5. Now, 12 squared is 144. 144 minus 2 times 8 times 5. When this number are multiplied together, you subtract it from 12 squared, we are going to have V squared equals to 64. If that is the case, then we have V, by taking square root to both sides, I have V equals to 64 square root of 64. Square root of 64 gives me 8 meters per second, which means the velocity of this body at when it reaches 5 meters is 8 meters per second. Now, to find the time it reaches to reach this 5 meters, then I use let T1. Since here I use T, let me use T1 here. Let T1 be the time it reaches a height of 5 meters. Now, if T is the time, then I will use V equals to u minus gt. At 5 meters, what is v? V is 8. What is u? U is the initial velocity of projection. Minus g is what? 8 times t. Now, if I make t subject of the formula, I have t equals to 12 minus 8 over 8. Meaning that minus 8t come back to this side, it becomes 8t. 8 going back to this side, it becomes minus 8. So therefore, I have 12 minus 8 over not t over 8, which is the coefficient of this t. Now, this gives me 4 divided by 8, which is 0.5 second. Now, the time for which it stays above a height is capital letter T. Now, T equals to, here is T1. I'm sorry. T equals to small letter t minus T1. Small letter t is 1.5. T1 is 0.5. 1.5 minus 0.5 is 1 second. This is our final answer, which is the time for which it stays above a height of 5 meters, meaning that it takes this body 0.5 seconds from here to this very point, and from this point to this point it takes 1 second. The total time of the journey is 1.5 seconds. If you enjoyed the video, give it a like and share, and follow for more so that more people will benefit from what we are doing. Thank you.